Once we understand the basic syntax of the different loop structures, what makes them useful is that there are a variety of ways you can use loops to solve problems. In this video, we're going to solve a problem that uses strings. We're going to ask the user to input a sentence, and then we will use a loop to count up the number of vowels in that sentence and then output that result. As always with these videos, they are much more useful if you stop at this point and try to solve the problem yourself, then come back and play the rest of the video to compare my work to yours. I have created a project for this solution, and the only thing I've added before I started recording was a write line statement at the bottom to pause my window so we can see the results, and then my header block. And as always, my first step is going to be thinking through some test cases for this. And so the basic idea is that I'm going to take a string from the user and I'm going to return some kind of an integer, right? A number of the vowels that were in the sentence. So as always, the test cases are important. I want to have just kind of a good old-fashioned standard sentence here. So I'll put Go Broncos. I'll add some punctuation to make sure that we appropriately handle punctuation. And the test cases are pretty easy to solve, right? I just go through and count the vowels. 1, 2, 3. Now that particular test case has a couple concerns that I want to make sure I address. This really only checks to see if there are any O's. It just so happens that that sentence only has the letter O in terms of vowels. So I'll need a test case that has additional vowels besides just the letter O. And it also turns out that all of these are lowercase letters. So I'll want to have a test case with some capital letters as well. Okay, so this is a longer sentence. It has more variety of letters, and it also has some capitals in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hopefully I'm counting right. It does happen sometimes that your test case is calculated wrong, and when you run your program, you sometimes realize that you messed up your test case, and in that circumstance, you actually come back and fix your test case, which sounds a little bit backwards, but mistakes happen, right? And I'm sort of an unusual one here, but an edge case, what happens if the user doesn't type in anything, or if they type in a string that doesn't have any vowels at all. We should make sure that it handles those cases correctly. So that's not the most thorough test case in the world, test case set in the world, but that's a good start. The last pieces that I'm concerned about are I don't see the letter E tested any place, or the letter U, and I haven't figured out what to do with the letter Y. A-E-I-O-U, sometimes Y. The problem doesn't state in this case what to do with that, so I think it's kind of up to us. I'm going to ignore the letter Y for now, but I do want to address what will happen if I have the letter Y in one of my test cases, and so I'm not going to attempt to be creative here. I'm going to have that as a test case. So that picks up the letters that I hadn't tested for before, and it picks up this letter Y. So the important thing here is that E and U count as vowels and Y doesn't. So there we go. If you chose or if you choose to count Y as a vowel, that's fine as well. You would just put 3 as your test case result there. So I think that's a pretty good set of test cases, at least good enough for us to get going here. And sometimes as you work, you realize you need additional testing data. I didn't think you needed to watch me type all the general overhead kind of stuff that we need for this problem. So this is what I've done. I've created two variables, one for input and one for the number of vowels that I've found. I initialized both of them to some default values. I prompt the user for a sentence and collect that input. I am going to have to count the vowels, and I haven't written that algorithm yet, but I did go ahead and skip down to the bottom to output the results. So I'm just going to output the contents of that vowel count. And if I run this at the moment, I get a place to enter a sentence, and it just outputs that there are 0 vowels in that. So the heart of this problem is going to be counting up the vowels in this sentence. And I can imagine a couple different ways to do this, but what I want to do is demonstrate what I like to call a traversal. So a traversal, for me, is a loop that moves through a chunk of data and processes that data in some way. And I'm explaining it very generically because we're going to come back to traversals when we study arrays. This time we're using it with a string. And what I mean here is that I'm going to examine this input one character at a time by traversing it. I'm going to start at the first character the user has entered. I'm going to determine if that's a vowel or not. Then I'm going to move on to the second character and the third character and the fourth character, as many characters as they are. And an appropriate traversal, a correct traversal, starts at the beginning, it ends at the end, and it doesn't miss any along the way. As silly as that sounds, that's the idea of a traversal. And one phrase you'll hear me use is that a traversal moves through correctly from beginning to end, and it touches each element along the way. In this case, it touches it by checking to see if it's a vowel. So the idea here is I need a loop that goes from the first character to the last character. And remember that strings are indexed starting at 0. So if you think back to our study of strings, all of the valid indices or indexes for a string run from 0 to whatever the length of the string is minus 1. So if we have 10 characters in our string, the valid indexes are 0 through 9 inclusive. So I need a loop that counts from 0 to the length minus 1. I can use any loop structure I want. You can use a while loop or a do while loop if you would like. A for loop is made for situations like this, and students sometimes are afraid of for loops or aren't as comfortable with them, so I like to demonstrate them often. And so I'm going to make an int called I, short for index. I'm going to start it at 0 because that is the first valid index in my string. It's going to keep going as long as I is less than the length of the input. And I don't have to subtract 1 from it in this case because I am saying as long as I is less than length. So when I is equal to 9, the loop will still process, will still iterate. But once I becomes 10, then it won't if my string has 10 characters. So that works correctly. If you are using less than or equal to, then you would have to subtract 1. And either one is acceptable, and you will see examples of people using both of those. And then with every iteration of the loop, I want to increase I by 1, so I'll use my increment operator there. So that's my loop, and hopefully it is set up correctly. In terms of bounding is the term we would use. It's bounded from 0 to the length minus 1. And within this loop, what I want to do is I want to pull each letter one at a time. So I'm going to make a a char or a char if you prefer to pronounce it that way, and I'll just call it the current character. And I need to get whatever character is at this particular index. And so there are actually, I believe, a couple ways to do this, but one thing I can do is just use this idea of what we call an index. Okay, and so what this does is the square brackets here indicate that I want to refer to an index, to one piece of that string. And so if I is equal to 0, it goes to the input string and it gets whatever character is at I, at 0. And as I increments and goes from 0 to 1, 2, 3, it will pull successive characters, right? And we will test this just to make sure it's working the way we want by outputting that. And so this is not part of my final solution to the problem. It's just a step along the way to see if this is working. And I'll go ahead and run this and see how it looks. So if I type in Go Broncos, which was my first test case, what I get is that it's pulling each character one at a time, and then it's outputting that with WriteLine. So it sort of takes my sentence, my string, and outputs it vertically. And again, that's not part of the requirements of the problem. It's just a step along the way for me to make sure I'm on the right track. Since I have pulled a single character from the string and I've verified that it's working correctly, all I have to do now is think about how to process that one individual character. How do I decide if it is a vowel or not? I don't have to worry about the fact that this is in a loop and what's it going to do with the next character and was the last character a vowel. All I worry about is this one character called curchar. Is it a vowel? And the solution I see most often from students, and it's a good one, is to just say is curchar, if curchar is equal to a, then vowel count plus 1. So that checks to see if the current character is a capital A, then that's a vowel, count it. To get all the other vowels checked, I have a couple different ways to manage this. I can start compounding these checks together using the logical operator OR. So if it's capital A or curchar is equal to capital E, now we'll check if it's an A or an E, and I can actually keep adding these OR statements on, and it might get to look a little ugly, but it works fine, and the compiler doesn't care if something is ugly. It's good at processing that kind of stuff. So that's a perfectly acceptable solution. Another approach I see from students who don't like to use or who don't think of that is to just have multiple if statements. Okay, so I've checked for A. Now I'm going to check for E, and then I can check for I, and I can check for O, and I can check for U. And that's a perfectly acceptable solution as well. The other idea I need to consider here is that I'm only checking for uppercase letters, so I also need to check for lowercase. And I can keep adding on more if statements. I can say, well, if current character is a lowercase a, if current character is a lowercase e, I can continue on like that. I can OR those on like that. But there is another way. I could also convert the string that has been input into either all uppercase or all lowercase, and then I don't have to worry about what case the user typed it in. So that I would address up here where the input is taking place. And so if I take that input and say to upper, that's going to convert the string to all uppercase. It doesn't impact any of the punctuation or spaces or anything like that. And otherwise leave it unchanged. So now, in theory, I should only have to check for uppercase letters. And so this approach actually should work fine. I can now forget about lowercase letters. I can either have a series of if statements, or I can have a bunch of or statements. If you're uptight about efficiency, you might notice that I can use else if statements, because once it's found that the letter is a vowel, it doesn't need to keep checking the rest. It can't be an A and an E, right? So once it's found that it's an A, it can skip, and that'll save us a little bit of processing, a little bit of clock cycles. And that's perfectly acceptable, and it's a solution that I see often. But I do want to take this time to mention that there is something called a switch statement that I don't spend much time on in the course, because you don't have to know how switch statements work, but a switch statement can be used here to very efficiently. I don't mean efficiently in terms of the computing, but in terms of my typing, I can make a very compact solution that uses a switch statement. So it's possible, if you know how to use switch statements, that you may have used one here. I'm going to pause the video and just finish typing up the rest of my if statements, and then I'll run my test cases. Okay, so here's what I ended up with. I haven't tested it yet, but I went ahead and just did separate if statements. I think I probably, if I weren't recording myself, would probably just use or, but this is fine. So at this point, I can now run my test cases and see if this code works the way that I want. And so if I've done a good job of designing my test cases, I can get a pretty good sense of whether or not it works just by going through these. So Go Broncos should return 3, and it does. Test my next case, 13, which means I counted correctly when I wrote that test case. And now these kind of edge cases that I wrote that don't necessarily look that intelligible, but they check to make sure I didn't miss any details here. And of course, if you think of something that is not covered by your test cases, then you can add them. And I would say you can even add them kind of informally. You don't necessarily have to write them down, unless it's something really significant that, like, ooh, I really forgot that I needed to check that. All of my test cases seem to work, so I think I am satisfied with this solution. I just wanted to emphasize again that I called this type of a loop a traversal. In this case, a traversal through a string. I'm going to move through the string one character at a time and process each character on its own, and I need to make sure that I am bounded correctly. I'm starting at the beginning, I'm ending at the end without stopping short or going over, and that I'm moving through and touching each individual character along the way.